Hey.
Okay, so I'm gonna share this screen. I'm gonna share this for right now, just so we can. Hello, hello.
Hello.
We'll just give it a couple of minutes. And does this show okay, the meeting notes screen?
Yep, I can see it.
Awesome, awesome, awesome. All right. All right, I want to thank, we get started in just one more minute here. Our first ever community meeting, very exciting.
Is this first time?
Hello?
Hello,
Yeah,
is this first time?
Yeah, this is the first community meeting. There was a lot of good, since we had started getting a lot of questions and discussion in the Slack channel, we thought it would be probably best to actually just host it as a meeting, an open meeting. So then we can also, record the conversation, share it, and let people kind of discuss, especially if it's related to a specific feature request or, Q&A, and also use this opportunity to share what people are doing with it.
Yeah, it's a good opportunity for us too, because as we scope out our features and our roadmap, there are implementation details and questions around conventions for things. And so getting feedback from users will help us guide actually the future of the product.
We also have, so let me just do this. I think the folks who did put in questions or agenda topics are all here. What I'm gonna do is add, so John Dang, what company are you with? Just so we can.
Oh, it's Cloud2Go.
Cloud2Go. And then John Joyce, welcome. What company are you with? Oh. John's on.
Hi, sorry, having a little trouble with the meeting link. I'm with Cisco.
Cisco, okay. And then let's see, Laurent, what company are you with?
Mute. Yeah, I found a mute. I'm with Roku.
Okay, cool. Awesome. Well, oh, and Michael.
Hey, yeah, I'm with AWS.
A lot of familiar faces from this, familiar faces and names from the Slack. I apologize if I don't remember where everybody, where everyone works. Michael, where do you work?
AWS. I'm a colleague of Alex.
Okay. So we've got a couple folks from AWS and Cisco, and then Roku and Cloud2Go. Anyone else, as they join, please feel free to type your name in there. So first of all, thank you for being so active in the community Slack and being interested in the project. In an effort to make this more community driven and be more transparent and engage everyone in the conversation, kicking off the first ever community meeting. Goal is to have this roughly every other week, but we can, if there's a lot, we can kind of, see how that goes based on if there's a lot of topics, or if there's no topics, then we can say, hey, do we skip a week, what have you. But part of this is to, one, do kind of like also open Q&A, have the agenda topics really driven by folks in the community, whether it be like, we've got questions here from folks at AWS around, at mesh support and support into the other AWS services. So that's a great discussion point. And then just other general questions, as well as like specific things that Solo is possibly thinking about as it relates to roadmap, and it might be like something that we have thought about internally, or maybe we heard through a private channel from a customer or end user, and we want to use this forum to kind of discuss with the larger group to get more feedback. So that's really the purpose of these. We will make a point of, I'll make a point of making sure that we post this into the community Slack on a regular basis so that the agenda is driven by everyone, but would like to have, one, see who's attending, and then go in and kind of do these topic points. And so this is fantastic. So we can actually, now that the welcome is done, we can start with the first topic, Alex, on plans for extending app mesh support. And so I know that's something that we've also talked about internally. So we can have one of our engineers talk about how we're looking at it, what we've what we've kind of thought about there, and then also open it up to the folks that on the AWS team for more conversation.
Awesome, thank you.
Sure, so I can give an overview about how we're supporting app mesh right now. So the extent of the support is the following. Once a user gives Service Mesh Hub their AWS credentials, assuming that the permissions are there, Service Mesh Hub can go and discover any existing app mesh instances. It can also discover any existing EKS instances. And the full set of functionality for discovery, figuring out what the workloads, services are, that's all working. We also have a very limited set of translation available. Right now, we can produce the virtual services, virtual routers, routes, as well as virtual nodes to represent each of the workloads. And we also, by default, can configure the backends of the virtual nodes to be able to communicate to any other service in the mesh.
Yeah, that's awesome. And I was really excited to see that update in version 0.5, I believe, released in late May. So today, we don't have AGA support for things like egress with virtual routers, but it's available in preview channel, and we expect to move it to GA within the next few weeks. Do you have any plans to support egress, to add support for egress?
We haven't discussed it, but that's something that we should definitely talk about as a group.
Awesome, because right now, the app mesh support is limited to discovery and configuration of the mesh itself. Basically, it gives you a good, well, potentially single pane of glass kind of view over your mesh. But in order to get service communication across different meshes, egress would be crucial.
Yeah, definitely. That's really exciting to hear. We've mentioned having app mesh to app mesh support. Just one question, do they have to be in the same, are there any regional constraints there? Can you have an app mesh instance in a different region talk to an instance in a different region?
Yeah, there should be no problem.
Cool.
The constraint would be probably account to account, but if you run these meshes in the same account in different regions, there should be no problem. Great. Even cross account already works, but it's more of a by account view and by region.
That makes sense. Okay, that's really exciting.
I sort of had a question on that, and maybe it's the next topic 2 down. But is there a roadmap posted somewhere for Service Mesh Hub, and how some of these things are put on the roadmap, or how do you get things on the roadmap if there's some ideas that people want? Or maybe you're going to cover that later on. I'm just curious.
Yeah, so part of that is this meeting is kind of like is starting kind of that public process for that. We wanted to use this to have kind of live discussion, and then start here. And then what we can do is, if you have you can start filing issues you know, with regards to like, hey, I'm interested in this. And then we want to start having some of that discussion happen here, as well as then move that to in the repo itself. But this is kind of, you know, we announced this open source and announced this just a few months ago. And so what we wanted to do is start having these discussions more publicly.
Okay, so if people had ideas or something that they wanted, maybe an important thing like an egress that Alex mentioned, the first thing to do would be to file an issue, and then if you actually wanted to propose solutions, how would that be done?
You know what we can do is we can also more formally like say like, hey, let's follow this way, and we'll actually we should put that into the repo itself, so that we're always like, you know, as a group doing that together. But I think that listing in here is one, especially, and then also in the repo itself, like as an issue, specifically as an issue, or you know. Just, you know, kind of like in a way to like discuss proposals in there. So, yeah.
Okay. Does the current community that you have, is there like a design? Do you put together a design write-ups for things, for all things, some things, no things? You know, what's the general process from inception to code?
You know,
I think Eitan can, or Harvey can answer.
Yeah.
Internally or externally?
We have design docs in the public repo, and you can basically do like something we do internally, but anybody can do it, is open up a pull request with a design doc that goes in that directory, and then we can discuss everything there. And, you know, seeing like the result, that'll usually lead to a pull request afterwards.
Okay, so it's not, design docs aren't like a mandate necessarily, but if the change is big, probably.
Yeah, I think start with an issue. We can always talk on Slack too, to like, you know, just have conversation. And then, yeah, if it's like a major change or like introducing an entirely new concept, I think it makes sense. Or yeah, if we're building out like a feature set, it can definitely be helpful to do, like if there's a substantial feature.
Yeah, I think raising an issue, I'll take an action item to create an issue template to help structure some of that. But I think an issue is a good first step. And then if there's initial consensus and we know we need a complex new feature, I think then we can make a call for a design doc. But definitely as a first step, maybe a design doc is a little bit too heavyweight, and we can create an issue first.
Yeah, I guess it depends on the scope of what the proposal is. If it's a minor, maybe an issue is good enough. If not, then maybe you need a design doc. Okay.
Right.
Makes
Yeah,
sense.
so I've added that to our notes here. And thanks, Harvey, for saying you'll take up that action. But so that we can put like you said, the issue template, and we could have some parameters on like, and this is a joint, this is a process with everyone. So we'll start there, and then we can kind of define like, you know, what would require doc, what doesn't, how we want to go through the discussion on the proposed feature.
Yeah, I was wondering if you maybe like the owners. I guess I'm not sure who the list of owners of the repos are, but they potentially could flag issues with like requires doc or something like that to call out what is expected to be resolved via consensus in a documentation form or PR review.
Yep, we'll do.
Oh, great.
And is there? I haven't dug through the like top level of the repo that much lately, but is there a list of the owners, and is that prominent in how we can contact them and stuff?
We don't have that in the repo yet. However, in the Slack channel in the channel description, we have a list of 4 individuals that you can feel free to DM with particular questions. But I will also add a list of the current owners to the the repo.
Cool.
All good question. All good questions. Anything else related to the process stuff? Any other questions or asks that you all have there that we can make sure that we kind of work into the repo?
Do you have a specific work group for each module?
Specific work group by module, do you mean like once, like for a specific feature that, for feature area, or? Can you
Yes.
explain more, Jen?
Yes.
Yeah, I think.
Currently we don't.
Yeah, so.
But I think if a particular issue evolves into like a milestone that we want to put more investment into, we can maybe like designate one of the owners of the repo to work with the community to push that effort across. But I think we can form those groups as needed. Right now, we don't have any formal distinctions.
Yeah, I think it's
Okay.
good, you know, when creating an issue or design doc or something, to just tag it with something like saying, oh, this is related to discovery. This is related to access control, you know, on Istio, something on that, to that extent. And
We have those labels right now.
Categorize things as they come up. But right now, it's just one. I think everything kind of goes into one pool.
John, are you looking to have, are you, with your question on work group owners, is that related to like, so who you would know to follow up with some discussion on, or is once a kind of a proposal becomes a feature for development?
Yes.
Well,
So both of them.
okay, go
Yes,
ahead.
yes to both.
I think I would want to be able to know the you know, decision maker for, I guess it's just to like clarity on if there's somebody who could point me at who they want to hear from or something like that. So how to move something along in the community, that would be the feedback.
Got it. Okay. Awesome. Okay. Anything else on this? And the other thing is, if you think of something after this call, feel free to add it here and then just tag one of us at Solo in there so that we know that you've added something. You know, this is not like a in place forever only document. You know, once it's typed, that's it. We can't add. It's not one of those. So, you know, we don't always all think of stuff during the meeting. Cool. So process was a good one. Alex, did you have anything else related to the app mesh support that you want to talk about?
No, not really, not at the moment. Thank you.
Okay, cool. And then Dominic, thank you for adding a bunch of stuff here. Do you want to kind of walk through the questions a little bit and then we can discuss?
Yeah, cool. So this is not process related at all. This is now more product related. So, and I had a few questions about the meta model or the conceptual foundation of Service Mesh Hub. I have been digging into Service Mesh Hub for a bit, and please do correct my statement or understanding where I didn't fully get it. So it looks to me that on a high level, Service Mesh Hub is a multi-cluster, multi-mesh solution. Service Mesh Hub has a strong notion of what a cluster is. One of the first things to do in Service Mesh Hub is to register a cluster. From there on, the Service Mesh Hub will identify an instance of a service mesh on that cluster. So I'd be interested in some of the intersections when we look at, for example, single cluster multi-mesh. If I have a single cluster, multiple Istio installations on that cluster in a sense of soft multi-tenancy. I'd also be interested in talking about what if you have multiple clusters yet a single mesh. And especially when we come to AWS AppMesh, I see a few discrepancies in the concepts. Seems beyond a cluster, Service Mesh Hub also has a strong notion of what a service is, and has a strong notion of a workload. So far as I can tell, the notion of service may be compatible. The notion of workload seems to be quite different. They are aligned when we compare, for example, Istio and Linkerd. They are fairly far apart when we look at Istio and AppMesh. And the discrepancies that I see right now is A, cluster, right? Service Mesh Hub deals in clusters, AppMesh does not. And Service Mesh Hub deals in workloads, which basically boils down to pods. AppMesh does not. Nodes, as far as I can tell in AppMesh, I'm not an AppMesh expert, but virtual nodes in AppMesh may also reflect, for example, a Kubernetes service, right? So it's on a completely different level. So I'm curious where the conceptual thinking, system thinking, the conceptual world is going to, and we can either stop there, or I can introduce the next question that is kind of aligned with that.
I think that's a great question. I think there's a lot to discuss here. Yeah, as you pointed out, the initial open source release of Service Mesh Hub was very much tied to a notion of a Kubernetes cluster. But since then, parallel to the work with integrating AppMesh, we have expanded the abstractions to be more Kubernetes cluster independent. What we want to represent is what we call a compute target or a compute platform, something that houses an atomic unit of compute. And I'd be interested to ask you, for the notion of workload, what can you elaborate on the discrepancies about the abstraction of a workload with respect to Istio versus AppMesh, and how you think they might not be compatible?
So in Istio, a workload, or in Istio and Linkerd, a workload basically boils down to a pod, right? So, and that is the thing that consumes a message.
Interject here. I mean, it's not entirely true. We know that Istio is also introducing support for VM-based workloads.
Yes, that is true. So then the workload is whatever consumes the message.
Mm-hmm.
And so I would argue that workloads are sources and targets of network traffic.
Yes.
And the atomic unit. In AppMesh, I would think that, but maybe somebody from AWS can correct me if I'm wrong on that one. The virtual node is not that. The virtual node, for example, can also represent a Kubernetes service, which in itself is then made up of workloads, or made up of workloads. So I would argue that the workload concept is different between them. Is that a big deal? I do not know.
So one thing I just want to say, so we're aware of these discrepancies and we've been planning around them. We have not, in the initial version of our API, it's all been very Kubernetes specific and, you know, working with those assumptions, which I think makes sense for the V1 Alpha 1. But we definitely have on our roadmap the ability to introduce more, like Harvey was saying, for different compute platforms. There are common concerns. I mean, ultimately, we know that we're dealing with an Envoy injected sidecar, which may be, you know, running wherever. If you're running in a VM, it may be hosted. But we know that there is a source workload somewhere whose traffic is going through, you know, an originating proxy and then, you know, arriving at either, you know, an external service or another thing in a mesh. So I do think that these abstractions are scalable. I mean, in the end, our API definitions boil down to our protobufs. So if you look at the protos and see how we could introduce, there's certain areas where fields may be turned into one-ofs, where we'll be able to select between different options, or we may introduce additional abstractions into the API in order to represent that, you know, like what exactly is a workload. Maybe we can have more types or a single abstraction point, but
you know, you actually said something interesting there. You could argue that the workload is represented by the proxy. So each proxy instance itself could be the anchor of one workload.
this is how we identify the workloads today, is based on the presence of the proxy sidecar.
Yeah.
So, and that's also how we know which control plane it's actually configured to, configured by. So if a user tells Service Mesh Hub, I want to configure workload A with some configuration, we know which control plane, you know, we know which namespaces the control plane is watching, and therefore we know which control plane to put the configuration to.
And for the discrepancies between workloads running on different compute platforms, part of Service Mesh's whole job is to handle those discrepancies. So from the user perspective, you can select workloads of heterogeneous types. Maybe they're running in different places. They have different data attached to them, but Service Mesh Hub, if it's implemented correctly, should be able to handle the discrepancies when it comes to actually doing the configuration management.
There, if you do not mind, I jump into the next question, since that is somewhat related. I do think that Service Mesh Hub may run into, even so that is basically more on the fringes. That is an edge case. May run into service discovery and workload drift. As far as I can tell, Service Mesh Hub discovers services via its own logic. So, for example, for Istio, you're looking for the sidecars, right? For Linkerd, you're looking for the sidecars. So when we look, a simple example, Linkerd, for example, just iterates over the pods. If for whatever reason they encounter an error in their iteration, they just do not consider this pod to be part of a service, right? So then the Service Mesh Hub would not do the same, since it has its own logic. When we look for Istio, I think Istio has fairly complex possibilities of including and excluding services and pods, so workloads for these services. This is all stuff that would need to be chased forever if you wanted perfect congruent view of the system. So my question is there also a notion or an idea, a plan to integrate with, similar to AppMesh, to integrate with Istio and Linkerd directly and ask the Istio and Linkerd instance for the services it knows and for the workloads it knows for these services?
So I think that when you use a platform like Service Mesh Hub, you understand that there are some trade-offs in terms of it being opinionated. I think that, you know, and there's definitely an approach where we could go directly to Pilot, let's say, and query the API there and get like a deterministic, definitive output of everything it sees. Or, you know, we can simplify, let's say, our own logic by, or make it closer to the corresponding mesh by actually importing exported functions from their libraries. Yeah, I think it's on a case-by-case basis, but it's natural to assume that there will be certain edge cases that will not be picked up or will not be regarded as valid. And maybe over time, as the project grows, we'll address more of those. But I think it's just a natural part of the trade-off that you have, right? When you're building on top of something.
And I think
no
to
question.
add on, oh, sorry, go ahead.
Mm-hmm. Yeah. Mm-hmm.
I was just going to say that it is our goal to minimize the drift whenever possible. So we try to pick a source of truth that we feel like is the most robust. And in the case of Kubernetes clusters, we feel like looking directly at the pods for the presence of the Envoy sidecar is the most robust source of truth.
Yeah, I think that, you know, we have to take a heuristic-based approach in the end, somehow, some way. So it's just a matter of trying to calibrate those heuristics. And that's why getting community feedback is so valuable, because there are always going to be, you know, a larger number of existing use cases and edge cases than we can come up with on our own. So that's just why it's very valuable for us. But I think as we're tackling the, you know, the 90 to 99% of use cases, ideally, we're in a happy spot. Are there
Cool.
any?
Thank you.
Yeah, sure. I'd be
Any
interested
other
to hear some of your.
questions to those or follow-up comments? No? Okay. Thank you, Dominic. Scott, you were going to say something?
Yeah, well, Dominic had before just mentioned that he had like some follow-up questions about app mesh. I don't know, maybe we can circle back to that at a certain point. I don't want you to lose them. Oh yeah, the other thing I wanted to address, and I actually wanted to ask the users or, you know, our community, maybe we can wait till the end. I put some notes in that I want to ask exactly about this question about preferences between one control plane per cluster, multiple control planes in a cluster, multiple clusters per control plane. And, you know, in those cases, we'll have to do, you know, the heuristic for resolving ownership, these like ownership hierarchies, what is in a mesh, which one belongs to which mesh, becomes even more complicated. And there, you know, I think there's even more concern about what we might potentially miss. So it's very important to us, I think, to hear about the different deployment scenarios that are being considered out there. Like, how are people actually architecting their control plane today? What's the desired architecture? So can we capture all those use cases, ideally with the smallest amount of complexity in implementation? But understandably, we may have to write, you know, separate modules to consider separate use cases. But we can come back if you guys have some thoughts on, you know, what the future of your multi-cluster control plane strategy is, and, you know, maybe you're using a solution that's sort of natively multi-cluster like app mesh, or you're planning to do your own with Linker to your Istio. It'd just be very helpful to hear how, you know, how you guys see it working. Are you going to use a flat network? How are your proxies going to connect to a remote control plane? Things like that.
Does anybody have any thoughts on that or comments at this time, or noodle and come back to it later? Or
I think like the Cisco guys here are, we're interested in the same sort of feedback from the customers or user base of at least for like anything like Istio multi-cluster. We have our own experience with our customers that deploy or internal users of mostly Istio, and it tends to land in the multiple per cluster control plane category, I would say. I don't know of any deployments of shared control plane. The multi-control plane per cluster is something we've seen interest in, but in discussions we haven't. I don't know if anybody's at least on the 3 people on the call, I've seen it with anybody actually doing that in a production environment. So we see kind of organizational boundaries driving it at the cluster and service mesh control plane level.
Yeah, so to echo what Tim said, I think we were not great people to be able to indicate what people want. You know, we do some of our own customer research. We have some internal customers. So we're very interested in seeing what other people want. But I'd almost extend this question to talk about also sort of the trust domain. Where are the trust domain boundaries? I saw Service Mesh Hub has something that they deem limited trust, but I'm not sure the scope of the implementation yet. But to me, the question we just asked is not just about how the control plane's segmented, but maybe more importantly, how the trust domains are segmented.
Yeah, so currently we have only implemented a shared trust scenario. So the various trust domains share a single root of trust, but on our roadmap is to implement a more restricted trust scenario, so you can have boundaries between your domains.
Yeah, sure. That's sorry. This was less a question of what SMH currently supports, and more a question of what might our customers want to support in any of these type of scenarios. Service Mesh Hub, Istio multi-cluster, just any kind of user feedback on that question was really what I was hoping for.
So the challenge there is imposed by the mesh, because right now we really only, you know, the smallest, I think ideally the smallest boundary would be to allow a user to define source and destination selectors like we currently have for traffic and access policies, and define that as a trust domain. And that way we could have a very concrete, you know, where basically it's up to the user, it's flexible to just determine what are those boundaries. But there are limitations as far as different meshes and how they allow you to configure them. Like maybe Eitan, I think, has context. You can correct me if I'm wrong, but I believe we can't define multiple trust domains within a mesh.
Correct. There's an Istio. There's like 3 lines of C++ that disallow you from doing that. That's something that's a feature that I think they specifically. I think that they're thinking that the trust domain should be essentially the boundary of any given like quote unquote mesh, or in our language virtual mesh. And so anytime you would have direct MTLS between workloads in a mesh, they would need to share the same trust domain.
Yeah, I mean, I understand that, and that's probably a limit. If SMH consumes, you know, basically the underlying mesh restrictions, that's true. But Envoy itself has a decent set of capabilities here.
Right.
So again, my question wasn't as much about what is currently possible in the code base. It was more about what do people want? Because I see, in my opinion, that when we start talking about what Service Mesh Hub is trying to do, you know, federate different meshes, the answer to this question is first and foremost, because you do want some limited trust that, you know, you've talked about, but not full trust, because you don't want everything in both meshes or all meshes to be equal and share the same root. So anyway, maybe it's a topic for a detailed discussion, because I don't know any of us have the exact answer right now.
Yeah, no, I think, like you said, I think it's a really interesting question. And, you know, as the space evolves, we'll learn more and more about people's, you know, best practices and people's preferences. If you read, you know, based on just like strictly Istio documentation and other mesh documentation out there, the limited trust scenarios seem, you know, I mean, it's always a trade-off, right? In the limited trust scenarios, you lose the identity of the individual workloads, but you gain the you have much you gain not you end up not all the workloads have to share the same trust domain or trust bundle. So what you lose in that individual MTLS, you gain in less shared information. So yeah, it's always a trade-off between these two different models.
Just one other thing, and I think this is relevant to both Dominic's question and the topic we're discussing now, which is essentially there are kind of two concerns. One is best practice, how to do something, and the other is what is the API of Service Mesh Hub and what will it support. because I think that we want to, there's some scale between doing everything and supporting only like a quote unquote best practice that, you know, somewhere in that gradient is where we want to go. So we're not necessarily only trying to implement the best, like the happy path, or, you know, like what we would consider to be a reasonable architecture or a best practice. But usually I think when we first scope out a feature, that is how we implement. So like in our initial implementation, you'll see us try to target, you know, the most common use cases or the ones that that we expect to see, because a lot of this is still pretty early stage.
That's totally fair.
But again, that's why the feedback in the community meeting is so valuable for steering this effort. Like we all kind of need to be informed by what each other are doing, because we're all pioneering this together, pretty much.
So I'm going to put that here. I added that to the questions area. Couple of things that our team added for just some discussion and feedback for like some future roadmap items. Harvey, do you want to take those two that we put in here?
Yeah, sure.
Yeah.
So one thing we've been curious about at Solo is the interest in the community for integrating Service Mesh Hub with other compute platforms other than Kubernetes. It's something that our abstractions currently support. We just have to go and do the work to implement additional compute platforms. Does anybody here have such an interest? Like for instance, integrating with ECS?
Well, obviously being a guy who works for AWS, I can say that definitely yes. We see a lot of customer interest in ECS. I mean, AppMesh customers run significant workloads with ECS. So adding ECS support would be crucial for customers that specifically use that platform.
Right.
I'd say yes also, like we have a lot of things already on ECS, and while I want some stuff to move to Kubernetes, it would be very useful to, it would ease the transition to a modern service mesh if we could support ECS and other Amazon stuff.
I see. And which service mesh are you looking to use with your ECS deployments?
Well, I mean, so the new things would probably be Istio based, and then it would interoperate with whatever we can do like on ECS.
I see.
Yeah, we have like a somewhat custom control plane for some part of stuff on ECS, but yeah, trying to move away from custom stuff.
Gotcha. Very interesting.
For clarification, did you also mention AppMesh in there, or does that not work on ECS? And I apologize if I don't know that.
AppMesh is the only service mesh, well, at the moment that is supported by Service Mesh Hub, and it can run on ECS. So yes, okay. ECS customers are interested in AppMesh. I don't believe that there is an easy way to make Istio work on ECS. It's going to be beyond the scope of this discussion.
Got it.
If you do not mind, I do not want to derail this particular question, but I do have a general design question. So for Service Mesh Hub, I understand that the concepts of a Service Mesh instance and service has to be a first-class concept. That is what it's all about. Can you shed some light on the reasoning why also compute platform and workload is a first-class instance?
I don't know if compute platform is represented as like a first class entity. We don't have that just yet. Workload is, however, a first class entity. And I guess the answer is just because we need an abstraction to represent an atomic compute unit, like a unit of the data plane.
Is that for reporting purposes? Or
specifically in, so I think that the way that we've modeled it is like this. This is the way I picture it. So your source is a workload. Source is a client, which we call a workload. Workload doesn't necessarily have a service to it. It's just making requests out to something in the cluster. So workload could be thought of as client, and the client is a pod. And I think Istio actually has the same abstraction. I mean, they have their own concept of workload labels that you can put directly on the virtual service. And what that does is it tells which sidecars to load the virtual service to. So I think we're basically saying the same model. We're taking from workloads to services, which may be backed by workloads, in order to get the graph of traffic, of communication. So in other words,
so you want the communication graph on a workload level?
Yes.
Right. Okay, gotcha.
We want to know where the traffic is originating so we can apply per source policies.
Do you envision an alternative abstraction? I'd be curious to hear what that is.
Oh, we can definitely brainstorm about it. I'm sorry, I'm just laughing because I usually chew John and Tim chew their ears off about that. So yeah, you don't know what you get yourself into.
Yeah,
so,
there's not enough time left.
But yeah, we can definitely take that offline and talk about that. So I generally I do like the abstraction of the service mesh instance and the service, because that if you only look at that level, that would immediately include single cluster multi-mesh and also multi-cluster single mesh, because you basically the compute platform is not represented anymore, cluster is not represented anymore.
Right.
And then also, if you work on that level, the AWS AppMesh virtual node is fairly much, it's basically the problem disappears. That is one. And then you can probably take that even further and then talk about, so Service Mesh Hub composes currently multiple meshes, multiple clusters. If you take it to that level, you can probably also have a fairly consistent API that lets you then, on top of that, compose multiple service mesh hubs, because that would be the next question in the recursive structure, right?
Right.
So if you get the underlying abstractions wrong, if you get the underlying abstractions right, then I think that trickles up nicely. But it's not an easy exercise, for sure. Yeah, it's not an easy exercise.
What I'm curious about is, how do you model source traffic, like the source for traffic in this, if you're only using services?
So I usually think of it's like on two layers, right? So it is definite traffic happens on a workload level, because that is where messages or the target of a message and the source of a message. However, if you fold that up into service traffic, right, then the source of a message wouldn't be, you cannot report on an individual workload. You could only report on a service, right? So it originates from that service, which has its own interesting
service for the workload.
Yeah, exactly. Which has its own interesting side effects. Yet usually we talk like, for example, the shopping cart service talks to the payment service.
Mm-hmm.
It's interesting if you realize payment service, you talk about service provider. The shopping cart service, who is the consumer, is also identified on the provider level, right? Because I call it the shopping cart service. you can take that all the way to the client. For the client, it doesn't work anymore.
So
Right.
I think like this is actually we've had this discussion a lot too, especially when we were initially designing. And I think that so there's a couple things that you mentioned. So I think that that is sort of like language drift among like within the word service, right? Like what is a service? Is a service the like in the case of the payment service, right? Is it the group of workloads which together do this thing, right? They do quote unquote payments, or is a service the target for for traffic that is bound for the payments group of workloads, right? So it's like I think that part of it is just a drift or a sort of not misunderstanding, but general like ambiguity of the word service in this space. And I think that for as I can only speak to Service Mesh Hub, but we chose the target of traffic for a given set of workloads, right? So you have like a bunch of you have your payments. Let's say your payments workloads, which are fronted by this, let's say in this case, Kubernetes service, which then forwards the traffic, whatever. It could be Istio, it could be a Kubernetes, it could be anything, which then forwards the traffic to these workloads. And so that's like that theoretical thing, which is accepting, it's like the service front. It's the thing that, it's the target of the internet traffic, which then gets doled out into a bunch of workloads. But that is what we are thinking of as the service. It's this theoretical.
Yeah.
Oh no, I just stopped sharing. Sorry.
Oh, okay. I was like, where'd it go? It's this theoretical thing. Sorry about that. It's this theoretical thing that is fronting a bunch of workloads. And so, you know, that's why our quote unquote workload is actually not a single workload. It is a group of workloads. So if you look at a mesh workload, the primary mesh workload is a deployment, which actually isn't a workload. It's technically more of a payments service because really it's a whole bunch of them potentially, right? It's potentially 1 to n rep or 0 to n replicas. And so really the mesh workload represents what is commonly also referred to as a service, which is all of the replicas for a given, you know, for a given app or not app, but service in this case. And then the service is just what, you know, is just the target of incoming traffic. Does that make sense?
I usually subscribe to the same notion. So I basically, I would argue there are two carrier sets. Number one, there are workloads and their identities. And number two, there are services and their identities. And a service can be a traffic target. I subscribe to the same notion. Yes.
I think that the way that we've modeled it is that a workload is definitively the source for traffic. Now, and a service is definitively the destination for traffic. And then with that knowledge, you know, we may, because it's an implementation detail in a sense that a workload is actually backing a service, and we can use that, but it's not an implicit assumption by the system. And so using that model, I still think we have a requirement to model our sources unless we decide that we're not going to have source level policy. But I don't think that we can abandon that abstraction, especially when it's actually surfaced in Istio. Although I believe that other meshes do not have that. But there are APIs that we want to consider which allow us to define the dependencies for each workload. So, you know, the Istio sidecar resource is an example of this, where you can explicitly say which routes you need to have surfaced, which clusters need to be available to the sidecar.
In AppMesh, they have the virtual node backends. achieving the same thing.
And that way, you know, again, we want to see from the perspective of the workload itself, and from the source essentially, which may or may not have a service fronting it. But even if it does, they're not, in terms of the system, they're not necessarily the same entity. You know, one is listening and one is a client. One is a server, one is a client.
Mhm.
The fact that they are both running in the same pod is it's abstracted from us. We can't. That's a common pattern. But just like the service itself, a Kubernetes service may or may not resolve to pods. So I think that we can take. We've been working mostly with the simpler case where they are backed by pods, but it's definitely our intention to support the full set of what Istio supports, which includes services with external names, services that route to external clusters, and so on. Does that?
Mm-hmm.
Cool. Thank you. I just wanted to do a quick time check because we're almost at an hour. I will say when we first kicked this off, I wasn't sure how many people were going to join the first meeting and if we were going to have a lot of discussion, but this is fantastic. And I think some folks here did mention that some of these topics you may want to follow up and discuss further. There are a few things that we didn't get to talk about. One of the specific ones here is we also were interested in getting some feedback on integrating with existing service meshes that may be installed in an environment for Service Mesh Hub. And we can take that up at the next meeting. And then if there's any other things that come up, please do put them in the notes for the next meeting, and we will hopefully see you all in 2 weeks.
All right, thanks so much, everybody. This is
Thank
very
you.
informative.
Thanks for
Have a
coming.
good day.
Talk to you more on Slack later. Bye.
Talk to you guys later.
Bye-bye.
Bye.